It is lunchtime on the 25th of September 1998 at the Esso Longford site. It is the primary provider of natural gas to the state of Victoria, Australia. For the most part, at least from the outside, everything seems normal. But it's not. It deals with highly flammable materials such as natural gas and oil, and represents a vital cog in local infrastructure and its economy. The morning has proved to be a little bit difficult. There had been difficulties in maintaining the system's temperature. This issue would become irrelevant when at 12:26 in the afternoon, flammable vapours were released. These would soon ignite, causing a conflagration, resulting in this. Today we are looking at the Esso Longford disaster. My name is John and welcome to Plainly Difficult. This video wouldn't have been possible if it wasn't for my YouTube, Patreon and Ko-fi members. If you'd like to support the channel financially, then you can from just £1 per month. And also check the pinned comment for all my links below for merch and other bits and pieces that I have up for sale. Longford. This is Longford in southeastern Victoria, Australia, which is around here on a map. It is home to a rather important piece of infrastructure, that is 3 gas and 1 crude oil processing plants. It has operated here since 1969 and is under the management of Esso, a subsidiary of the US company Exxon. It processes natural gas here from wells in the nearby Bass Strait. The crude oil it processes also comes from the Bass Strait as well. From the plant, crude oil and raw LPG is sent to Long Island Point for further processing to commercial LPG and stabilised oil for refinement. The natural gas once processed at Longford, however, is then dispensed to the Victorian Natural Gas Network. The natural gas works are done by 3 gas plants, named rather creatively GP1, 2 and 3. Now, the process roughly goes as follows. Gas comes in from the offshore fields via pipelines. It is cooled and loses its pressure during its journey along the lines to the onshore. The materials pumped from the fields contain methane, ethane, propane and butane, as well as water. During this time, water and the hydrocarbons become condensed and settles in the low parts of the pipework. These are known as slugs and can prove to be a little bit troublesome, as they can weigh several tons. When they reach the plant, the energy they carry is dissipated via things called slug catchers. These separate off liquid from the gases for further processing. This is done at the 3 gas plants. It passes through an inlet separator in each plant, which removes any free water and any other condensate. The gas then passes through molecular sieves in each plant to remove water vapour and hydrogen sulfide. Now, for the rest of this video, I will be focusing on just one of the gas plants, which is the first one built in 1969, named number 1. Anyways, the gas inlet is chilled by 2 heat exchangers to prepare it for the absorption process, which is better performed at colder temperatures. Gas plant 1 has 2 absorbers which operated in parallel. The gas was fed into the lower part of the absorbers at a temperature of -25 degrees Celsius. Each tower had internal trays all the way up it. This allows gas to rise and for oil to be fed at the top to drip down via the help of gravity from each tray downwards. As the oil dropped from tray to tray, it absorbed a lot of the heavier components shed from the gas, for example, the ethane, propane and butane that it contained. The lean oil was thus made rich, as it was saturated with the hydrocarbons. Condensate carried in the cooled gas dropped into a lower tray in the absorber, and this was taken off for further processing. In order to help remove it, it was warmed up using a heat exchanger and goes via its own flash tank. The gas taken out of the top of the absorber is then taken off for sale as natural gas for consumers. Operators for gas processing plant 1 were informed of the system's status via equipment in the control room. Due to its age dating back to 1969, the instrumentation was a mixture of pneumatic equipment installed at the plant's vintage and a much newer computerized system. Now the site ran 24 hours a day and was staffed as such, with 2 12-hour shifts formed by 5 shift teams. Right, so now we've got some kind of idea of how the plant worked and a rough overview of its operations, let's move on to the main course of our video, the disaster. The disaster. It is the morning of the 25th of September 1998, and Gas Plant 1 was dealing with a large buildup of condensate in absorber B. The condensate could only go to two places: the condensate flash tank, or overflow into the rich oil line to its own flash tank, the latter of which being less than ideal. Eventually, the condensate level rose to such a point that it was unmeasurable by the plant instrumentation. This was a sure sign that it had risen into the rich oil section of the absorber. The decrease in temperature and rise in condensate level caused the valve to close, regulating the flow of two vital pumps, which played a part in circulating the lean, warm oil to the absorber. This caused them to shut down, thus cutting off the flow of warm oil to the absorber, but gas was still being inserted into the system, which was still bringing in more condensate. The increase in cool condensate and lack of warm oil caused the system temperature to drop. The shift operators tried to restart the pumps, but to no avail. However, they could have been overridden if placed into test mode, but no one had been taught this. Parts of the system temperature dropped to minus 48 degrees Celsius, with the absorber reducing to minus 25 degrees. Heat exchanger GP905 was starting to show visible signs of icing on the outside along its pipework. This was around 8:38 in the morning. All the time the gas was still being added to the system, a decision to shut Gas Plant 1 down was made. Arrangements had to be made to divert the gas from Plant 1 to Plant 2. The transfer was completed at roughly 11:30 in the morning. The decision to start up the gas plant was made at around 12 p.m. Heat exchanger reboiler for the lean gas, GP905, was absorbed to have formed quite a large amount of ice over its outer shell and uninsulated sections. Operators decided to reduce the flow of lean oil throughout in order to not cause a rapid change in temperature, as this could cause a fail and rupture in the heat exchanger. An operator was sent down to operate a valve to reduce the flow. However, some confusion in communication resulted in the wrong piece of equipment being operated, thus the flow to GP905 was still full. When the operations restarted and the pumps whirled back into use, an estimated flow temperature of 230 degrees Celsius was sent to the heat exchanger. At roughly 12:26 p.m, the brittle steel of the exchanger's outer shell failed due to the quick change in temperature. The rupture released over 10 tons of hydrocarbon vapour into the atmosphere. These were highly flammable. The cloud travelled for roughly 170 metres for around 60 to 90 seconds, until it found some fired heaters, and then went and caught itself alight. The deflagration burnt back to the leak source, and a jet of fire shot out underneath the pipe rack junction, causing 9 more leaks. The plant supervisor and maintenance supervisor were killed during this initial part of the fire. The flames would continue to burn for 2.5 days, creating more and more leaks and more fires. This was because of how long it took to completely isolate Gas Plant 1 from all the flammable material. Gas services would be halted for consumers for 2 weeks, causing significant issues for local industries and residential properties, which brought an economic loss estimated at around 1.3 billion Australian dollars. The site processed roughly 37.7 thousand barrels per day of LPG and over 188,000 barrels of crude oil per day. Thus, this caused a very large financial shock to local industry when it was shut down. So needless to say, the disaster would result in an investigation, and being in Australia, it would be dug into via a royal commission. In our case, it was headed by former High Court Judge Darryl Dawson and was launched in October 1998. The investigation. So almost straight away after the fire, investigators from Esso descended upon their severely damaged site, and they began poring over the remains and interviewing their staff. Initially, Esso went down the usual big corporation route, trying to push the blame onto the site's operators, as noted in Andrew Hopkins' paper, Lessons from Esso's Gas Plant Explosion at Longford. The company argued that operators and their supervisors on duty at the time should have known that the attempt to reintroduce warm liquid could result in brittle fracture. But this wasn't exactly true. The inquiry took a different view, again quoting Hopkins here. The Commission took the view that the fact that none of those on duty at the time understood just how dangerous the situation was, which indicated a systematic training failure. I'm more inclined to agree with the inquiry here, as Esso was known at the time to prioritise downtime incidents in its training. This can lead to focusing on getting things up and running quickly, but always not in the most safest way. The inquiry would settle on 4 main issues. The site was needlessly complex, meaning isolations were difficult to undertake. Poor training of personnel and operating procedures led the operators to become confused and operate the incorrect equipment. Poor communication between shifts, especially on the night and day shift handover on the disaster day. And finally, the way the control systems worked, in that they gave excess alarms, desensitizing staff to serious issues. So a forensic investigation would also be undertaken on the failed part of the reboiler, and it was found that the failure had occurred at a weld seam. As the warmer oil was pumped in, the outer section still remained cold, and it was this joint where the failure had occurred. The difference in temperature caused a stress fracture in the casing of the reboiler. The reboiler was normally operated at a temperature range of between 60 and 230 degrees Celsius, which was a sudden shock from the minus 48 degrees it had been subjected to during the shutdown. In the aftermath, Esso received a fine of $2 million Australian dollars in July 2001, followed by a class action suit from consumers for loss of earnings due to the gas outage. This would be settled out of court, and finally, on top of all that, the company had to pay $32 million Australian dollars in property damage, in addition to the sum $400 to $500 million in damages to their own plant. The disaster was unfortunately all too common. Operators doing the wrong thing in a rush, but trying to save pennies for the company only ever results in a much bigger cost. So that's my video on the 1998 Esso Longford disaster. It's going to be a 3 on the scale, and this I've got for my root cause analysis card. Do you agree? Let me know in the comments below. This is a Plain Difficult production. All videos on the channel are Creative Commons Attribution Share Alike licensed. Plain Difficult videos produced by me, John, in a currently moderate corner of southern London, UK. And all that's left to say is thank you very much for watching, and Mr. Music, can you play us out please?